Good day, my dear SS2 students, and hello everyone out there. My name is Mr. Seun Akinmolayan from Sleek Angels International School. I'm a physics teacher. Today we shall be looking at some calculations using the mirror formula. Previously, we have considered plane mirror. We also considered curved mirrors and types of curved mirrors. We considered the uses, that is the application of curved mirror. But today we want to look at how we can solve some problems based on curved mirror. Let's go. The topic is mirror, like I said earlier, and the class is for SS2. So we're looking at calculations using mirror formulae. We have some formulae on the board here. Magnification M equals V over U, where V equals image distance. V equals image distance. And then U equals object distance. Okay, so the first one is magnification, which is M equals V over U. The second one we have also magnification, which is image height over object height equals image distance over object distance. Now, any of these formulae could be used depending on the question. You can use image height over object height equals image distance over object distance, depending on what you're looking for. And then the third formula, we have 1 over F equals 1 over U plus 1 over V. 1 over F equals 1 over U plus 1 over V, where F is focal length, U is the object distance, and then V is the image distance. And then the fourth one, we have F equals UV over U plus V. Now, this fourth one is actually derived from the third one. If you play with the third one and then you make F the subject, you're going to have UV over U plus V. And the last one, the number 5, is M, which is still magnification, equals V over F minus 1. This is also derived from number 3. If you play with number 3, if you multiply all through by V, you're going to have M equals V over F minus 1. Alright, on the basis of this formulae, we'll be looking at some examples. We have 3 examples today. So we're starting with example 1. Alright, example 1. An object of height 2.5 centimeter is placed 20 centimeters from a converging mirror of focal length 10 centimeters. What is the height of the image? I take the question again. An object of height 2.5 centimeters is placed 20 centimeters from a converging mirror of focal length 10 centimeters. What is the height of the image? Okay, let's look at the solution. Solution. When you have a question like this, it is very good for you to list out your parameters. List out those parameters you are given in the question. For example, an object of height 2.5 centimeter. So we can write out that quickly. Object height equals 2.5 centimeters. And then we also told that the object is placed 20 centimeter in front of a converging mirror. So we have object distance equals 20 centimeter. So if object height is 2.5 centimeters and object distance equals 20 centimeters, then we have to find the height of the image. But before you can find the height of the image, you need to find the distance of the image. The distance of the image. We're also given the focal length. We're given the focal length. Focal length F equals 10 cm. So having all this, then we can go with one of the formulae we've already given earlier that says 1 over F equals 1 over U plus 1 over V. 1 over F equals 1 over U plus 1 over V. Now, you can substitute the parameters given so that you can now find your V, where the V is the image distance. So let us substitute and see what we're going to have. 1 over F, given that F, which is the focal length, is 10, so we have 1 over 10 equals U is the object distance, so we have 1 over 20, then plus 1 over V. So 1 over 10 equals 1 over 20 plus 1 over V. Now, as a student of mathematics, you can make 1 over V the subject. If you make 1 over V the subject, you're going to take 1 over 20 to the other side, knowing fully well that 1 over 20 is already positive at the right hand side. So when it's coming to the left hand side, the sign changes. So you have 1 over 10 minus 1 over 20 equals 1 over V. 1 over 10 minus 1 over 20 equals 1 over V. Therefore, you can find the LCM from here. If you find the LCM of 10 and 20, you have 20. So you ask yourself, how many times can 10 go in 20? That's 2 times. 2 times 1 will give you 2 minus 20 in 20. That's 1. That is how many times can 20 go in 20? That's 1. Then 1 times 1 will give you 1. Everything here equals 1 over V. So from here, 1 over V equals 1 over 20. 2 minus 1 equals 1 over 20 equals 1 over V. So 1 over V equals 1 over 20. If 1 over V is equal to 1 over 20, then what is V? Making V the subject, you can cross multiply. So if you cross multiply here, you have your V to be equal to 20 centimeter. So V equals 20 centimeter. But that's not the question. The V is just the, or that's not the answer rather. The V is just the image distance. You were to calculate the image height. Therefore, using one of the formulas also given, where you have image height over object height, everything equals image distance over object distance. So if you substitute what we have, image height has already been, image height is what we're looking for, so we have image height over object height. Object height has been given 2.5 cm equals image distance. We've calculated that 20 cm over object distance. Object distance is also given to be 20. So you discover that 20 can cancel 20. 20 cancels 20. Then image height over 2.5, everything there equals 1. Then you can cross multiply such that you now have image height equals 2.5 centimeters. The image height equals 2.5 centimeters. Okay, Let's move further to example 2. Example 2. We have a concave mirror of radius of curvature 30 cm produces an inverted image 3 times the size of the object placed in front of it. Determine the object position and then the image position. Determine the object position and the image position. I read the question again. A concave mirror of radius of curvature 30 cm produces an inverted image 3 times the size of the object placed in front of it. Determine the object position and then the image position. Let me quickly remind you here that concave mirror and converging mirror, they are the same thing. Another name for concave mirror is converging mirror, while another name for convex mirror is a diverging mirror. So you should be able to understand the differences and also the similarities. Now, in this case, we were also told that the image produced was 3 times the size of the object. What does that mean? That is magnification. It therefore means that the magnification is 3. So if the magnification is 3, then it means the image is 3 times the object. Okay, so let's look at how such a question can be solved. Okay, solution. Let's write out our parameters from the question. The first thing we're given is the radius of curvature. So we have radius of curvature. R equals 30 centimeter. Radius of curvature equals 30 centimeter. Then focal length. We know that our focal length F equals R over 2, which means 30 divided by 2. So F equals 15 centimeters. 15 centimeters. And then we were told that the magnification is 3 times, that is, the image is 3 times. So let object U be X. Let object U be X, because we're not even given the size of the object, neither the size of the image. So let object U equals X. If object U equals X, and then we're told that the image is 3 times the object, it means whatever U is, the image, the V will be 3 times, will be multiplied by 3. So let image V equals 3x. Since from the question we were told is 3 times. So if U is X, then V is going to be 3x. Using 1 over F equals 1 over U plus 1 over V. Let's substitute what we have. 1 over F, where our F is already 15, equals 1 over U. Our U is X, then plus 1 over 3x. So 1 over 15 equals 1 over X plus 1 over 3x. From here, you can find the LCM. The LCM of X and 3x is 3x. So X in 3x is 3. X in 3x is 3. 3 times 1, 3. Plus 3x in 3x is 1. 1 times 1 is 1. Then we have our 1 over 15 here. 1 over 15 equals 3 plus 1 over 3x. So we have 1 over 15 equals 4 over 3x. If 1 over 15 equals 4 over 3x, then you can cross multiply. Cross multiply. If you cross multiply, you have 3x equals 4 times 15. 4 times 15. So 3x equals 60. If 3x equals 60, what is x? Divide both sides by 3. Divide both sides by 3. Divide both sides by 3. So you have 3x over 3 equals 60 over 3. So 3 cancels 3. You now have your x equals 60 divided by 3. You have 20 cm. So if x, which is the object, equals 20, then what is v, the image? So if x, which is the u, the object distance, equals 20 centimeter, what is the image distance? So a, therefore, a, object position, u equals 20 centimeter. Then b, image position, v equals 3 times 20. Since v is 3x, then 3 times 20, so v equals 60 centimeter. So it means the object position is 20 centimeter, while the image position is 60 centimeters. So we're looking at example 3 right away. Let's go into example 3 right away. All right. A man stands 45 centimeters in front of a concave mirror of radius of curvature 1.2 meters. Deduce A, the nature of the image. B, the magnification of the image. A man stands 45 centimeters in front of a concave mirror of radius of curvature 1.2 meters. Deduce A, the nature of the image. B, the magnification of the image. All right, we list out our parameters as usual. Solution. A man stands 45 centimeters in front of a concave mirror. That man is the object. So the distance between the man and the concave mirror is 45 centimeters. So we call that object distance. Object distance. U equals 45 centimeters. Then the mirror is of a radius of curvature 1.2 meters. Radius of curvature R equals 1.2 meters. But we know that F, which is the focal length, equals R over 2. R over 2. And that will give you 1.2 divided by 2. So F equals 0.6 meters. The object distance was given in centimeter, 45 centimeter. So you can't work with meter and centimeter at the same time. You need to make your conversion. So 0.6 meters. How many centimeters make 1 meter? How many centimeters make 1 meter? 100 centimeters make 1 meter. 100 centimeters make 1 meter. Therefore, 100 multiplied by 0.6. So F equals 0.6 times 100. So F equals 60 centimeters. You can now work with your object distance and your focal length. They are both in centimeters. So you can work with them and then get your V, which is your image distance. Okay, using 1 over F equals 1 over u plus 1 over v. Let's substitute our parameters. So 1 over f has been given to be 60, so we have 1 over 60 equals 1 over 45 minus 1 over v, plus 1 over v. 1 over 60 equals 1 over 45 plus 1 over v. We find the LCM. Before we do that, let's bring 1 over 45 to the other side. And when you do that, the sign changes. When you do that, the sign changes. So you have 1 over v equals 1 over 60 minus 1 over 45. 1 over v equals 1 over 60 minus 1 over 45. Because 1 over 45 is positive at the right hand side. Coming to this left hand side now, the sign will change. So coming to meet 1 over 60, the sign changes. So you have 1 over v equals 1 over 60 minus 1 over 45. So if you find the LCM, you have 1 over v equals the LCM of 60 and 45. You can just do your calculation quickly. The LCM of 60 and 45 is 180. 180. So you have 180. 180. So 60 in 180 is 3. 60 in 180 is 3. 3 times 1, you have 3 here. Minus 45 in 180. How many times can 45 go in 180? Is 4 times. Then 4 times 1, you have 4. So 1 over v equals 3 minus 4. 3 minus 4 equals minus 1 over 180. If you make v the subject of the formula, then that means you cross multiply. Then v automatically will give you minus 180. The image distance is minus 180. And then the question says, what is the nature of the image? The nature of the image is determined by the distance of the image. By the virtue of this answer, minus 180 means that the image formed is virtual. And from our previous lessons, we have said virtual image is formed behind the mirror. So, and they have negative signs. So what that means is that the nature of the image formed by the virtue of this, our answer, minus 180 centimeter, means the image is virtual. Image is real when the image distance is positive. So it means real images, like we said before, real images are formed before the mirror, in front of the mirror. Whenever an image is formed behind the mirror, what you have is called virtual image, and the sign is negative. Of course, by diagram, it's represented with broken lines. Therefore, if v equals minus 180 centimeter, automatically the nature of the image is virtual. So A, we can say that the image is virtual. Why? Because of the negative sign. So let's put it in bracket. Distance is negative. Distance is negative. Distance is negative. So the image is virtual. That is the nature. If you worked and then you got positive answer, it means the image is real. But anytime you have negative answer, it means the image is virtual. Now the second question says the magnification of the image. And of course, B, we know that magnification M equals V over U. Magnification M equals V over U. We have U already, which is 45 centimeter. U is 45 centimeter, and we just got V. V is 180 centimeter. In calculation, you don't need to use the minus. Why? the minus or the negative sign is just telling you the nature of the image. It's not going to be used while you're calculating. So you have n, which is the magnification, equals 180 over 45. And so from here, it means that n equals 4 centimeters. M equals 4 centimeters. M equals 4 centimeters. So the magnification of the image is 4 centimeters. It tells you the image is 4 times the object, is 4 times the size of the object. Okay, this is how far we can go today with problems and calculations involving mirror formulae. We'll look at the assignments. We have assignments today. So I have an assignment for you. I call it home drill. We have the home drill. You need to just see how you can practice with this question at home, and then you send it to me. So let's look at the first question. Number 1. An object is placed 10 centimeters in front of a concave mirror. An object is placed 10 centimeters in front of a concave mirror of focal length 15 centimeters. Determine A, the position of the image. B, the nature of the image. An object is placed 10 centimeters in front of a concave mirror of focal length 15 centimeters. Determine A, the position of the image and the nature of the image. The second question, the position of an object placed in front of a converging mirror of focal length 0.1 meters is 0.15 meters. Deduce A, the position of the image, B, the nature of the image, and C, the magnification of the image formed. Deduce the position of the image, the nature of the image, and the magnification of the image formed. When you are through with this homework, please kindly forward it to my WhatsApp number on 08034796589. 08034796589. Or you can send it to my email address on princeoluwaseun91@gmail.com. princeoluwaseun91@gmail.com. All right. I hope today the questions we have solved have been able to dissolve so many issues in your heart. I know that so many of you might have some questions relating to calculations using mirror formulae, but with these questions, I think you should be able to go ahead and practice other questions, even outside the one we have given, and then you discover that they are very, very simple. But I must say that in case you have any other question outside this, even from the topic and previous ones, don't hesitate to send it to my WhatsApp number and the same email address. I hope you had fun during this lesson. All right, see you in the next class. See you. Bye.